In this video, we want to learn how we can reverse the order of integration in double integrals. Our first example is double integral of the function f, which x changes from 0 to 2y. So x is between 0 and 2y, and the y is from 0 to 1. So y is between 0 and 1, plus the other integral from the function f again. But here x is from 0 to 3 minus y, and the y is between 1 and 3. So the region is described, as you can see here, in two parts. One part of the region is the region that x is between 0 and 2y, and the y is between 0 and 1. And the other part is described this way. For changing the order of integration in double integrals, first we have to draw the region. We have to sketch a graph from the region. Then we can change the order of integration. Here, the given integral is in terms of x first, then with respect to y. So we want to change the order. So we want to write this integral, this double integral, the sum of these two integrals in the form of double integral of the function f with respect to y, then with respect to x. We want to reverse the order. And now we have to sketch the region, these two regions, and then by looking at the graph, we can find the lower bound, upper bound, lower bound and upper bound for x and y. So first we have to start graphing the region. Here, if you pay attention, x is between 0 and 2y. X equals 0 is the y-axis. So x starts from this vertical line, x equals 0, and it continues up to x equals 2y. So x is from 0 and it ends at x equals 2y. If we solve this equation for y, then y equals x over 2. The reason that we have to solve this equation for y is that finally we want to write the lower bound and upper bound, or lower limit and the upper limit for y, and it should be in terms of x or any number. So for that reason we have to do this. So x is again from 0 to y equal x over 2. Y equal x over 2 is a simple line that its slope is 1/2, because x over 2 is basically 1/2 x. This line passes through origin, because if you plug in 0 for x, y is 0. And if we plug in 2 for x, 2 times 1/2 is 1. So it passes through the point 2, 1. So when x is 2, the y value is 1. So this line passes through 0, 0 or origin and the point 2, 1. So the line is something like this. This line is something like this. Attention, x starts from this line and it continues to the right up to this line. So we are in this region. But attention, we have another condition. Y, in the region y is between 0 and 1. Here y is 0, at here y is 1. So we are limited only in this part of all of this region. So these two equations here together, they describe this small triangle that you can see here. Now let's draw the other part of the region, which in here x is from again 0. So x again starts from this line and it continues to this line, x equal 3 minus y. So here again x starts from 0 and it continues to the line x equal 3 minus y. If again we solve this equation for y, y equals 3 minus x. If we move y to the left and we move x to the right, we get to this equation. y equal 3 minus x is a line that its y-intercept is 3, so it passes through this point, and its slope is -1, so when we move 1 unit to the right, we move 1 unit down, 1 unit right, 1 unit down, so it passes also through this point. So this line is passing through this point here and also here. Attention, if we plug in 2 for x, then the y value 3 minus 2 is 1. So it also passes through this point. So the graph of the line is something like this. And attention, we have another condition. Y should be between 1 and 3. At this point, y is 1. At this point here, y is 3. So this small triangle here is this region. So these two equations together, they describe this triangle here. So our region is this part also. Now here we want to describe this triangle in terms of y, then in terms of x. To do that, when we want to describe y, usually it's a good idea to draw vertical lines or vertical arrows like this, and you have to pay attention to the points that these vertical lines enter to your region. So attention, our region is this triangle that you can see here. This is the region. When we draw vertical lines like this, these vertical lines enter the region at this line, if you pay attention. So this is the region. They enter to the region at this line. What is the equation of this line? The equation of this line, if you pay attention, the equation of this line is x equal 2y or y equal x over 2. Here we want to describe or write the lower limit of y. So we use this equation. So y starts from x over 2. So the lower limit for the integral is x over 2 because y is x over 2. What about the upper limit or upper bound of the integral? These vertical lines exit or leave the region at this line. What is this line? This line is y equal 3 minus x. So the upper limit of the integral is 3 minus x. What about x? Because x is the outer integral, here we have to write numbers. If we look at this triangle, in this triangle, the smallest value of x is 0, and the maximum value of x is at this point, which is 2. So x changes from 0 to 2. So x is between 0 and 2. And this finishes the solution of this question. So we reversed the order of integration from dx dy to dy dx. This is the process that we have to follow for all the questions like this. We have to sketch a graph of the region, then we have to update the lower limit, upper limit of the new order, and this should be done like the process I described for this question. Let me show you more examples, and a little more complicated examples, so you understand this technique better. Now look at this question. Again, we have two integrals from same function. The function is f. In the first integral, if you pay attention, x is between y minus 2 and the radical y. And y is from 1 to 4. In the other integral, y is between 0 and 1, x is from negative radical y to radical y. Again, we have two regions, two parts basically. We have to draw these two regions, and then we have to try to describe that region in the reversed order. If we reverse this, then the new integral should be in the form of f of x and y dy dx. So, as usual, first we have to sketch a graph for the region. Please attention that here we have two equations. X is between y minus 2 and radical y. We have to graph x equal y minus 2 and x equal radical y. And y is from 1 to 4. And also, in this region, we have x between negative radical y and radical y, and y is between 0 and 1. Let us start for this question to sketch the graph of these equations basically, because they seem simpler, a little simpler. Y is between 0 and 1, and x is between negative radical y and radical y. So we have to graph x equal negative radical y, and we have to graph x equal radical y. Attention, if we solve these equations for y, from this equation, if we raise both sides of this to the power of 2, we have y equals x to the 2. So x to the 2 equals y, or we can say y is x to the 2. Also, if we raise both sides of this equation, this other equation, to the power of 2, we get same equation, y equals x to the 2. You should be familiar with this famous equation, y equals x to the 2. It's a parabola. It's upward. It starts from this point, 0, 0. Its vertex is at origin, and it continues up. Attention. If we plug in, for example, 2 for x, the y is 4. So at 2, the y value is 4. And at negative 2, the y value is 4. So the graph of this parabola, or basically these two equations, is something like this. The graph of the parabola is something like this. Attention that the reason that these two equations, when we raise them to the power of 2, they give you one equation, same equation, is because this equation is the right side of the parabola. So the graph of this equation is this part of the parabola, this branch of the parabola. And this equation shows the other branch, or this side of the parabola. So x equals negative radical y is this side, and x equal radical y is the other side of the parabola. But attention, here we are limited for y. We have a condition for y. Y is from 0 to 1. So we have to only consider part of this parabola, that the y is from 0 to 1. 1 is here for y. So we have to ignore the part of the parabola that is above y equal 1. So the region that these two equations describe is basically here, only this part, because y is from 0 to y equal 1. Now let's focus on the other equations. Y is from 1 to 4. So here y is from 1 to 4 to here. For the left side here we have x equal y minus 2. So if we write this equation, basically we have x equal y minus 2, which if we solve this for y equals x plus 2. Y equal x plus 2 is a line with a slope 1 and the y-intercept is 2. So this line is basically something like this. Its y-intercept is 2 and its slope is 1. So if we move 1 unit to the right, 1 unit up, 1 unit right, 1 unit up, 2 unit right, 2 unit up, so it passes also through this point. So it crosses this parabola at this point here. So the graph of the line is something like this. Attention, it also passes through negative 2, 0, because if from this point we move 2 units to the left, we go down 2 units. So the graph of the line is something like this. What about the other side? What about the equation? This equation basically, x equal radical y. From here we have x equal radical y, which if we raise it to the power of 2, again we get y equals x to the 2, which already we have its graph. And because this is x equal positive radical y, so it is this side of the parabola, not the other side. Remember, this left branch of the parabola is for x equal negative radical y. But here we have x equal radical y, so it's only this side of the parabola. So, finally, what is the graph of these two equations that here we have? These two equations together, they describe the region below this line from 1 to 4. Basically, they describe this region. Please attention. X starts from y minus 2. So x starts from this and it continues to the right up to radical y. Radical y is this parabola. So x is between this line and this line from 1 to 4. If you want to understand this better, you can draw, because this is x, you can draw horizontal arrows like this. They enter the region at this line and they leave the region at this equation. So this part that is between them is the region, and because y is only between 1 to 4, so we are limited to this part. If we had not this condition here, then it continues down. So finally, the region is this that I am shading here. Now we want to describe this region in the opposite order, in the reversed order. We want to describe first, we want to write a limit for y, then for x. Again, to find the lower limit and upper limit for y, we draw vertical lines. If we draw vertical lines, by drawing vertical lines, we have these lines, for example. As you can see, these lines enter the region at this parabola. They enter to this region at the parabola, which its equation is x to the 2. So the lower limit for the integral is x to the 2. What about upper limit? again, if we draw these vertical arrows, they leave the region at this line, which its equation is y equals x plus 2. So we have x plus 2 here. And for x, what about x? X is, the smallest value for x is -1, and its maximum value in this region, if we pay attention, the smallest value of x is -1, and the maximum value of x for all the points on this region is 2. So x is between -1 and 2. So we have -1 here and 2 here. And this completes the solution of this question. Now look at this question. Double integral of the function f with respect to y, then with respect to x. Y is from x to 1/2 radical 20 minus x to the 2, x between 0 and 2. We want to reverse the order of integration here. So we want to write this double integral in the form of double integral of the function f with respect to x, then with respect to y. And as usual, we have to sketch first the graph that these lower limits and upper limits describe. Then we have to update and we have to find the lower limit and the upper limit for the reversed order of integration. X is between, y is between x and 1/2 radical 20 minus x to the 2, and x is between 0 and 2. From the left equation, from the left inequality, we have y equal x or x equal y, which is this line. Its slope is 1. It passes through the origin is this line here. What about the other equation? What about y equal? What about y equal 1/2 radical 20 minus x to the 2? This is a little harder equation to graph. Let me remind you something first. If you remember, x to the 2 over a to the 2 plus y to the 2 over b to the 2 equal 1. This is an ellipse. This is the equation of an ellipse. And this ellipse is something like this. This point is a, this a here, and the point that it intersects y-axis is at b and -b, and this point is -a. This is something that you have to remember. For example, if we have an equation like x to the 2 over 4 plus y to the 2 over 9 equal 1, this equation is an ellipse that intersect x-axis at a square root of this number 2 and -2. So it intersects x-axis at 2 and -2, and it intersects y-axis at 3 and -3. And the graph of the ellipse is something like this. Here is 3 and here is at -3. Now that we remembered the equation of ellipse in general, let's see what we have here. To graph this equation, to graph y equals 1/2 radical 20 minus x to the 2, if we raise both sides of this equation to the power of 2, we have y to the 2 equals 1/4 20 minus x to the 2. If we multiply both sides by 4, we have 4y to the 2 is 20 minus x to the power of 2. If we move x to the 2 to the left, we have x to the 2 plus 4y to the 2 equals 20. And finally, if we divide both sides of this equation by 20, we have x to the 2 over 20 plus 4y to the 2 divided by 20 is y to the 2 over 5. 4 over 20 is 1 over 5 equals 1. Now, if you compare this with the general form of equation of an ellipse, you can see that this is exactly equation of an ellipse, that it intersects x-axis at a square root of 20 and negative square root of 20. A square root of 20 is something close to 4.5 because 20 is between 16 and 25. A square root of 16 is 4. A square root of 25 is 5. So a square root of 20 should be between them. It's something between 4 and 5. And it's almost in the middle. So 4.5. So this is an ellipse that intersects x-axis at a square root of 20, which is 4.5 almost, somewhere here. And it intersects y-axis at a square root of 5 and negative square root of 5. A square root of 5 is 2 point something, 2.2 almost. So the ellipse is something like this. This is the graph of the ellipse, almost. This is a rough sketch of the graph. Please attention, but not all of this ellipse is y equal 1/2 radical 20 minus x to the 2. This is important to notice. Only the upper part of this ellipse is the graph of this equation. But why? Let me explain to you why we should not consider this lower part as the graph of this equation. Only the upper part of this is the equation, is the graph of this function. First of all, attention, if we consider all of this as the graph of this function, then this graph is not a function, because if we draw vertical lines, they intersect the graph of the graph at more than one point, and we know that when we draw vertical lines, it should intersect the graph at most at one point. So this cannot be the equation, the graph of this equation. The reason that only the upper part of this graph is the graph of this function is that y equals positive 1/2 radical 20 minus x to the 2. So y equals something that is positive. If y is positive, it cannot include these points here that lie here. All of these points that are below x-axis, the y value of all of these points is negative. So this equation cannot represent these points. So the graph of this equation is only this part of the ellipse, the upper part of the ellipse, from negative 4.5 to 4.5 almost, from negative radical 20 to radical 20, and this point is a little above 2, which is radical 5, which radical 5 is 2.2 almost. So this is the graph. But attention, x is between 0 and 2. We have the other condition. If x is from 0 to 2, attention, 2 is exactly the point that the ellipse and this line intersect. Let me show you the reason why they intersect exactly at 2. So finally, what is the region that these two equations describe? The region is between the ellipse and the line when x is from 0 to 2. From 0 to 2. So the region is basically here that I am shading right now. Let me erase my ellipse to the right a little if I can better. If you pay attention in this region, y is between x and 1/2 radical 20 minus x to the 2. Y is between x and 1/2 radical, which is this equation, and x is between 0 and 2 in this region. But let me explain to you why we know that the ellipse and this line exactly intersect at 2, 2. It is clear that if we plug in 2 here, y is 2. So this line passes through 2 and 2. Let's check that if this ellipse also passes through 2 and 2. If we plug in 2 for x in this equation, y equals 1/2 radical 20 minus 2 to the 2. 20 minus 4 is 16. Square root of 16 is 4. 4 times 1/2 is 2. So this ellipse also passes through these points. So they intersect at 2, 2. The other thing that you can do is to set this equation equal to this equation, solve this equation for x. You can see that they intersect at 2. Now we want to explain or describe this region in terms of x, then in terms of y. To do that, we have to draw horizontal arrows or lines like this, and we have to check that where they enter the region and where they leave the region. Please attention, this is very important. This point that the ellipse and the line intersect is 2, 2. If I draw this here, this line here, this segment of line here, now if you pay attention, if we draw arrows like this, when the arrow is above this, above 2, they enter the region at 0. They leave the region at the ellipse. But if the lines like these two is below this x equal y equal to, so for these two, please attention, for these two lines, if you pay attention, they enter the region at 0, but they leave the region at this line. So it seems that we cannot describe this region in terms of one integral. So I have to write here two integral for function f, then dx dy. Again, what is the reason for that? Because depending to the lines, to these horizontal lines, if they are above 2, like this one, they leave the region at the ellipse, which its equation is this. But if they are below 2, like these two, they leave the region at this line. So for that reason, we have to write two integrals to describe the region. Now let's focus on the region that lies below y equal to. Here, x is changing from 0 and it continues up to this line. What is this line? This line is x equal y or y equal x. Please attention. The equation of this line is x equal y or y equals x. So the upper limit for the integral is y here. What about y in this region? Please attention. Our focus is at this triangle now. In this triangle, y is changing from 0 to 2 because this point is 2. So y is from 0 to 2. Now, what about the other part? Let me erase these two. Now we want to describe this small part that you can see here. This part. Again, x is from 0. It leaves the region, the arrow leaves the region at this ellipse. So we have to solve this equation for x because I want to write x in terms of y here. So I have to solve this equation for y. If we solve this equation for y, basically we did the calculation here. We can use our calculation from here. And if we use this equation, x2 equals 20 minus 4y to the 2, if we take a square root, x equals plus minus radical 20 minus 4y to the 2. The reason that we have to only consider the plus sign for x is if we consider negative, negative shows this side of the ellipse. But we want the equation that describes this side of the limit, which x is positive here. So we consider only the positive sign. So x here, the upper limit or upper boundary for the integral is radical 20 minus 4y to the power of 2. And y is from this, which is 2. And this point here, let me erase these extra things from here if I can. So y is from 2 to this point. What is this point? This point is the y-intercept. And what is y-intercept? If we plug in 0 for x here, or actually we can find it from this equation, but it's okay to use this. If we plug in 0 for x, y is 1/2 radical 20, y is radical 5. So this point is radical 5. And also, if you remember, I explained that the ellipse, the equation of the graph of the ellipse, intersects the y-axis at radical 5 and negative radical 5, if you will remember. Anyway, the y-intercept is radical 5. So the upper limit for this integral is radical 5. I hope by watching this video you have learned how to change the order of integration in double integrals, especially when the question is not a simple region. If you like this video, please subscribe in my channel and see you in the next videos.